Hello there, children. Today we're going to be working on section 8.5, so let's go through the notes. So, this is on properties of logarithms. We have a couple properties of logs here. So, let us begin.
Let's do some math. Let's do some math.
Okay, so now let us begin. The first one is called the product property. What the product property allows me to do is simply take a log that is two things multiplied together and simply split them apart. This is going from left to right, called expanding, because I'm taking one log and I'm expanding it into two different logs.
I had to learn how to do math.
So, for example, if I have the log base 7 of 8x, I take it as a log base 7 of 8 plus the log base 7 of x. So let's think here.
Even though it makes you sad.
Now, the log here, and the trick is that multiplication, which is right in the middle of that x and y, gets split up with addition. Now, going from left to right is expanding. If I wanted to essentially Humpty Dumpty these back together again, I will do what's called condensing. So this is the product property. Let's move on. Now the next is the quotient property. Why is it called the quotient property? Because it takes the log, which is a quotient, two things divided by each other, and splits it up. Now, unlike the product property, a quotient is split up by subtraction. Think of the division bar in subtraction like they almost look the same. That's how you can tell the quotient property. So, for example, if I have the log base 7 of 9 divided by t, the numerator goes first, so it's a log base 7 of 9 minus the log base 7 of t. The denominator is the second one. Now, you might be wondering, why in the world am I doing any of this? Well, when we go to solve, it may be easier to have multiple logs, because I can figure out what one of these things are, or some of these things might cancel out a little bit. Or, for solving logs, it may be easier to essentially Humpty Dumpty these things back together again and take multiple logs and bring them back as one log. So, let's move on. The next property I have is the power property. Now what the power property allows me to do is anything that has an exponent, I am able to drop that exponent down in front of the problem. Now we can go over the proof of this. Just think of an exponent. If I had like x squared, it's just x times x. Well, guess what? X times x would use the product property. So all the power property is just an extension of that. So what it allows me to do is anytime I have an exponent, I can drop it out in front of the whole log here. So for example, if I had the log base 7 of x to the 6th power, I'm able to have 6 log base 7 of x. This would be fully expanded, as it were. Now, let's continue. So what do you do when you see a problem like this?
So I called Mr. Faust. I said, can you help me figure it out? Can you please help me figure it out? Test coming up, I need 100%. Yeah, I need 100%. I just have to figure out how much I spent.
What would I do here? Well, first off, now this is a product because it's 5 times x to the 3rd. So what do? I split it up with an addition sign. The log base 6 of 5 plus the log base 6 of x to the 3rd. I put an addition sign in there. Is this fully expanded? No, because I have that x to the 3rd sitting right there. That's not okay for a full expansion. So what I have to do, anything that has an exponent, you simply drop out in front as a coefficient. There we go. That would be an expansion of a logarithm. Now, if I went from the bottom to the top, started from the bottom, now we're here, that would be condensing. Let's move on. But what happens if we have a different log base other than 10 and e? Like some of you on the homework problems ask me questions like, hey, Mr. Faust, all these problems are log base 10 or log base e. My calculator has them. What if they're not? What do I do? So two things. One, your calculator might have the ability to put in different bases. If you have a graphing calculator, it may be under the Math tab. And if you click that, you're going to have something that looks like this. If I insert an equation here, a log for instance, you would have something that looks like this, where it gives you a spot to put a base and a spot to put a number. If you don't have that, then no, you don't unfortunately have the ability to change the log base on your own. You may need what we call the change of base formula. What this means is simply you can take and use log or ln. Why would I do those? Because my calculator has both log and ln. So if I have the log of any base, in this case log base x of y, it converts to one of these. Easy way to remember which one is which: the base goes in the basement. So look how it's log x ln x and then log y ln y. You can use either one. You're like, well, what does it matter? It doesn't. It's a ratio. The only thing that matters is if you pick log of y up top, you need to pick log of x on the bottom. This is not Burger King. You cannot have it your way and do like ln of y and then divided by log of x. That won't work. The base is in the bottom. Base goes in the basement. Now, if I had this, the log base 4 of 15, I could write it as ln of 15 divided by ln of 4. Notice how my base was 4, so it goes in the basement. Because I changed the base here, and I picked the two bases I know my calculator can have. That's a good thing. Now, if your calculator has the log button that you can change the base, like right up here, this particular one, you should get the answer of 1.953 when you do this. If you don't, shoot me an email and I can gladly walk you through some calculator things. There are calculators you can convert these online too. So now go henceforth and do.
I said, let's do some math. Yeah, we gotta do some math. I had to learn how to do math so I could count all my cash.
You guys did want rap music. You just didn't know I had someone actually make me a rap song back in the day.
Let's do some math. Let's do some math. Even though it makes you sad.